so let's start streaming, guys. I believe we are live and I hope so that I'm audible. Hello. Yep, I am audible and I am live. Let us start the live stream. Okay. Hey guys, welcome back to Coders Arcade. I know, yes, I know, I am back after so many days. You thought that I'll be gone, I'll not be doing any other, episodes, but it's not like that. We just started with our graphs concept, and how is it possible that I will leave you guys all alone on this very important graphs concept? I'll never let this happen. But actually the problem was, apologies for the days that I have taken in between. Actually I was out of station. Also I was outside, I was outside of the station, and also I was down on my health. My health was also not good. So that is the reason why I was not able to come live. But guys, I am back now, back with our concept from where we left. We will continue this live stream and we will continue until we finish this up. Welcome back to Coders Arcade. Welcome back with your host Ashank David for today's live session, where I will be teaching you data structures and algorithms. Today's concept is going to be graphs concept, and guys, without any further ado, let's get right into the topic. So those people who are joining new, let me just tell you, I was not available for just for a few 4-5 days in between. I was out of station and I was not well also. Now I'm all well. A little bit of problem is there, but yeah, it is okay. Now it is fine. We are going to back. I'm gonna able to take the class from now on to till daily. Okay. So without any further ado, let's get right into the topic. Now before I start with this live stream, guys, I would like to request you people to please like, share and subscribe to our channel Coders Arcade, and don't forget to press the bell icon also, so that you won't miss any future updates. Alright, so and don't forget to share this live stream as much as possible, so that this live stream can reach those people also who are in the need of learning DSA all for free, and this is all for free. So these videos, these things we are all covering all for free. We have covered a lot of things in depth and detail in past, so if you haven't watched those videos yet, I would recommend you to watch those videos and come back to this video. Now let us talk about what we have done in the previous live session. So if I see what we have done in the previous live session, this was the PDF actually which we have done, and this is all about, you can already see that it is all about learning graphs. We have started with graphs concept. Yes, we have started with graph concept, guys, and here we have done all these things. So we have understood what exactly are graphs and how they look like, right? What are the uses, what are the different types of graphs, okay, what are the degrees, what are paths, what are in degree, out degree. We have talked about the weights, unweighted, weighted. We have talked about the traversal in the graph, where we have talked about the breadth first search, depth first search. We have talked about the types of graphs. A lot of things we have done. We have done graph representation also. Okay, so here in the math we represent it like this, and in adjacency matrix we represent it like this, and yep. So today we are gonna see these two things basically. In today's live session, we are going to write our first code for our adjacency matrix, and if time allows, we will write the code for adjacency list also, guys. So stay tuned for more and upcoming videos. If you haven't watched our live stream number 33, session number 33 on graphs, please go ahead and watch that also, and we will continue. Alright guys, let's start. So we are back here into our blackboard, and let us start with the graph representation. Alright, and I hope so that I am audible. If I am not audible, please do let me know, and if there is any issue with the camera, please do let me know, because I am the only one handling myself, all this camera and all these things. I am handling it all by myself. Alright guys, let us start then. Okay, so here we are going to talk about graph. We have already studied about graphs. What are graphs? Graphs are data structure, and all the introduction part and briefing part we have already done that. Sir, what happened to session 32? What happened to session 32? Session 32 is not available, or what? I believe so that session 32 should be available. Let me check. Session 32 is not available, or what? '30, '31, '32. Yes, it is available. Oh, okay. It is not uploaded, I guess so. It is not uploaded till now. Okay, so if there is any issue related to this, I will definitely solve this. So that is fine. That is okay, guys. Jamil Rahman, I will be checking that out later on. Stay tuned for that, and I'll try to resolve that. Okay. Yeah, 32 is there actually. Yeah, 32 it is visible only. The live stream recording is not available, it says. Okay, I will check. No worries. Let us continue in this live stream, and whatever is the problem, I will check and I will resolve it. Now, without any further ado, let's get right into the topic. Hello sir, hello Ronnie, hello sir, hello, hi. Sir, Java classes will continue from this week. Yes, definitely Java classes will be continued from this week as normal, as usual. Saturday to Saturday we will be coming live. Last week we were not able to come live, me and Saurav sir, because of we both were in outside project. We were outside stationed, and we were not able to, and plus I was also sick, so I was not able to take up the regular online daily DSA live sessions. XYZ. Hi Ronnie, please. Jamil Rahman, I will check for that video. Okay. Now let us continue. In today's class, we are going to talk about graph representation. So we have talked already about graphs a lot, and when we were talking about graph representation, we have understood that graphs can be represented in two major ways. Before we represent that in two major ways, mathematically, graphs can be represented in G of V, E, where G stands for graph, V stands for vertices, or in this case nodes, and E stands for edges or the distance between two nodes. Okay, we have understood about this. This was basically in maths, but when we are talking about in coding, the first type of representation of the graph would be adjacency matrix. What? It was adjacency matrix. Now, adjacency matrix. Suppose we have our graph. Let us say this is our graph. let me create a nice looking graph. Okay. Let us say 0, 1, 2, 3, 4, 5. Okay, like this. Now I have named the nodes like this 0, 1, 2, 3, 4, 5 like this. Suppose this is the graph. This is the graph. Now if I say that guys, you need to tell me the adjacency matrix representation of this graph, then what it would be? You would create the 5 by 5 matrix, and that 5 by 5 matrix starting from the nodes. So 0, 1, 2, 3, 4, 5. Similarly here also 0, 1, 2, 3, 4 and 5. Okay guys, like this you would have created the whole matrix, correct? So now in this matrix you would be putting up the weights wherever, in whichever coordinates the weights are available. For example, in this case, do we have a node from 0 to 0? No. So from 0 to 0 we will say 0, where 0 means there is no node, where 1 means 0 to 0 means there is no edges between those particular nodes, 0 node and 0 node, there is no edges. From 0 to 1, 0 to 1, is there any edge? Is there any edge from 0 to 1? Yes. So you will put the edge weight. Now remember guys, I am writing the edge weight. So the edge weight will be 0 to 1. Here there are no edge weights given. That means I can just imagine it that I can take it by default as 1. Okay. Then do we have the weights from 0 to 2? No. So 0. 0 to 3? No. 0 to 4? No. 0 to 5? No. I hope so that this is clear. 0 to 3 it is available. So I will say 0 to 3 it is yes. Alright guys, I hope so that this is very much clear. So 0 to 3, 0 to 1. Okay, now we will talk about 1 to 0. 1 to 0, yes, because this is unweighted graph, this is undirected graph, and when we are talking about undirected graph, the directions, the edges can be in both the directions from 0 to 1 or 1 to 0. So in this case I can say that yes, from 1 to 0 the edges exist, and I will put that one right here in this matrix. Well, I hope so that this is very much clear. And from 1 to 1 there will be no edge. See guys, remember that from the node itself to the node to node, or from the node to the node itself, there will be no edges. So directly you can fill 0, 0, 0, 0, 0 in the diagonals. Understood this? I hope so that this is very much clear guys. Okay. But for the other places, from 1 to, yes, it exists. 1 and 3, yes, it exists. That means 3 to 1 will also exist, and 2 to 1 will also exist. 3 to 0 will not exist. I hope so that this is very much clear. So if 1 to 2 is existing, then 2 to 1 will be also existing. If 3 to 1 is also existing, then 1 to 3 will also be existing. Like this I'll be just filling up that. Well, if you are doing this in programming, slowly you will do it. One by one you will do it by getting all the nodes and vertices, whatever it is. You will never leave anything. Then speaking about 1 to 4, is there any? No, nor it will be. So 0 and 0 for 1 to 5 also, because I can see that there is no node existing. From 0 to 1, 0 to 2 to 0, no. 2 to 1 it exists. Okay. 2 to 2 it doesn't exist. 2 to 3, yes, it exists. That means 3 to 2 also will be existing in this case, this one. and then we will say 2 to 4, which is existing, yes. 2 to 4 is existing, yes. That means 4 to 2 will also exist, and 2 to 5 is also exist. That means 5 to 2 will also get exist. Understand my point, guys? Like this you will be doing it. Now I am just filling it very fast actually, because you can see that I have very less time and I have to explain you all the things very thoroughly. So I am gonna do it like this. Now speaking of the other ones, if we start from 3 to 0, yes it is. 3 to 1 it is, yes. 3 to 2 it is, yes. 3 to 3 it is not. 3 to 4 it is, yes. 3 to 4 it is, yes. So that means 4 to 3 it will also be yes, and then 3 to 5 it is no. So it will be 0, and 5 to 3 also will not be equals to 0. Then if we talk about 4 to 0, then 4 to 0 doesn't exist. 4 to 1 we have already seen, it doesn't exist, it doesn't exist. So this will not be there. That means 1 to 4 also, yeah, okay, 1 to 4 doesn't exist. So 4 to 0 will not, or 4 to 1 will also not exist. 4 to 2, 4 to 2 does it exist? Yes, it exists. Okay. Then 4 to 3 it exists, yes. 4 to 4 it doesn't exist. 4 to 5, yes, it exists here. So 4 to 5 it exists here. That means 1 to 4 also it will be existing. Then 5 to 0, no. And then 5 to 1, no. 5 to 2, yes. And yeah, this guys is your adjacency matrix representation of your graph, where this is the graph. I hope so that this is very much clear. Now I have already explained you this before. Now it is time for us to program, guys. Time for us to program. How the hell would I program this thing, and where it should accept this graph? It should accept, your program should accept this graph and your thing. So they are mirrored in the diagonal for undirected graph. No, this is undirected graph only, no? Jamil Rahman, this is undirected graph only, no? So it is not mirrored. It is not mirrored, just for the sake of fast execution and fast understanding, because we have done this in the previous live session. I have done it very fast. So for that I was putting, if it is 0 to 1, then it will be 1 to 0 also, because it was undirected. If you can travel from, let's say, suppose you can travel from 3 to 4 in this direction, that means you can travel from 4 to 3 also in this direction, because actually this whole thing is undirected. I hope so that this is very much clear to you, all of you guys. Correct? Actually the graph in itself is undirected. There is no directions given. This was just the starting index, so I was just showing you, but there is no direction given. If there were any direction given, in that case the thing would have been different. Then I could have said, I mean, matrix is symmetrical. No, it is not. Kind of, yes, you can see, yes, kind of like that. You can see that it is very symmetrical, but not all the places it is. It depends upon how the nodes are placed, what numbers are placed where, but it is not. You see, if you divide this into this symmetry, then the here one is there, here one is not there. You see, here one is there, here one is not there, like that. So not necessary always that it will be in the symmetry, depending upon this particular graph. Okay. It doesn't matter with the concept of is the graph, is the matrix symmetrical or not. It is just the way of representing the graph in the terms of matrix, in the terms of two-dimensional array. I hope so that this is very much clear to you. Okay. Jamil Rahman. Okay. We'll move on. Correct. We will move on. So this is how your matrix would represent. Not necessary that it should be in symmetrical or asymmetrical. Now the question is how to code for this. how to code for this particular thing. How to code? That is our question. How to code? Okay. So let us talk about this. To code for this, first of all, to code for this, first of all, we need to understand how would you create a matrix. Just on the last, in session number 31 and 32, oh guys, my camera went off and we are back. And yep, we are back. Yeah, we are back. Yeah. Nothing happened, just camera went off for a moment. Yeah, and we are back. So guys, how to code for this? Now before in the session number 31 or 32, 32 is down. I will be seeing to that why it did not get uploaded properly. If it is not getting uploaded, I will upload it again. But session number 31, I have explained you about vectors. I hope so that you have watched that video. If you have not watched that video, then you can use normal arrays. If you have watched that video, then you can use vectors with me. But I will highly recommend using vectors with me. Understood? It makes our lives much more easier. Okay? This is a two-dimensional array, and two-dimensional array can be taken like a normal array, or in this case I will be taking it as a vector. So let us see. I will be creating a vector which will be two-dimensional. It will be a 2D vector, which we have already studied in session number 31 and 32 of DSA live placement series. Okay. So we will talk about that to create the adjacency matrix. I hope so that this would be very much clear to all of you. Okay. So now, how will we create? If I had to create this matrix, I would create it like this. I would say vector of type integer, okay, and I'll say adj mat will be the name of my adjacency matrix. This is a two-dimensional vector of the size let us say if the size is v, vertices, number of vertices, then the inner vector of type int will be of size v, comma, by default it will be putting up the value as 0 by default. Okay guys, so it like this it would look like. I hope so that this is very much clear. This is what we are going to use in order to create our two-dimension matrix called as adjacency matrix. Okay guys, let us talk directly, go into the code and let us understand using this. So guys, this is the code for it. Let us try to understand the code. Okay. So here we started by saying hash include IO stream and hash include vectors using namespace std. We already know this. If I want to use vector and create any type of vector, either it is one-dimensional vector or it is two-dimensional vector, I have to include the vector in the program. I have created a class called as graph, and inside this class graph we have created two sections. One is private section of the class and another is public section of the class, where in the private section we have taken the v as the number of vertices. Later on this can be taken up using the constructor of the graph and initialize the value of this in the later on. So basically this is the attribute of this class called as graph, which is abstracted. If you don't know abstraction and if you don't know what I am doing here, you have to go ahead and watch our mastering C++ for DSA session. There are 5 sessions, 5.5 hour sessions are there. If you go ahead and watch that and master it all, you will be able to easily do the job of understanding this thing, because we are doing C++ object oriented and here we are using abstraction. So this is your abstraction, and here I am taking in the private section of the class, I am taking int v, and here we go, we have created a two-dimensional vector called as vector of type vector int adjacency matrix. I hope so that this is very much clear to all of you. Anybody any doubts, you can please ask me. After that, after completing our private section, in the private section of the class, just the two attributes are enough for V and the adjacency matrix. Later on, in the public section of the class, we went and we started by creating the constructor. The constructor would be like this: graph, class graph, int vertices are the parameter of the constructor, which later on when we will create the graph, we will call the constructor like this, and we will put the number of vertices and we will add the vertices by adding the edges like this. So in the constructor I have taken vertices which will be set it up to this V. I hope so that we are getting the point, that the private member which was abstracted now is getting initialized with the help of the constructor right here. Understood this? Then I have said matrix adjacency matrix dot resize, this adjacency matrix using the resize function. Now those people who don't know resizing, I have explained this in session number 32, just before my actual session for graphs was taken, and I know 32 session is down, I will be updating that very soon. Or you can watch 31st session, there I have explained you how exactly the resize happens. So I will say resize, and this V, as I have told you, is this V, which I have told you, this V I have told you is the number of vertices, and this is for the inner vector V. Okay guys, so adjacency matrix dot resize, this is the size of the outer vector, and this is the inner vector size and its default value. So we have created the two-dimensional vector, vector of type vector, we have resized it to the particular size, and the initialization is done as 0, and then we have created a function. So our constructor is over yet, and I have just initialized the vertices V and the adjacency matrix graph, that is two-dimensional graph. I hope so that this is very much clear. Now later on we have written a function to add the edges between U and V. Okay, imagine if there is two nodes, there is node U and there is V, and if I want to connect these two nodes, I would have to create an edge between them. So I have created a function called as add edges, add edge, and in add edge we have taken U and V. U is going to be my first node and V is going to be my second node. This U and V will keep on changing for different nodes across the graph, and will be adding and creating up the graph as well. I hope so that this is very much clear. So I have taken the adjacency matrix of ADJ matrix, which I have taken of U comma V, U and V. You already know it's a two-dimensional matrix, so U and V will represent I and J inside that matrix, that means row and column. That means U node to V node directly, and I am assuming that it is of weight 1 because it is an undirected and unweighted graph, so I am going to assume it as 1. If there was the weight given, then you could have added the weight parameter, and you could have just set to equals to that weight parameter. With the help of that variable you will be able to put the value, but right now we are doing it a very simple order to understand how it works. So I have taken it as normally as 1 as a default. I hope so that this is very much clear to all of you. Now because it is undirected, if there is a edge between U to V, then there is an edge between V to U also, guys. That means it will go, if it is coming in this direction, it will go back in that direction also. So adjacency matrix of V comma U also is set to 1. And guys, that's all. We have created the add edge function. Now just creating the add edge function will not work. We need to also print that matrix, right? This will fill up the matrix. But if I want to print the matrix, I need to print the vector also. So I'll print the adjacency matrix. So for int I equals to 0, I is going to be less than V, and similarly j will also be taken into consideration, and j will also be taken up from 0 to V and j plus plus, and we are just printing it like how we used to print normally a two-dimensional array or two-dimensional vector. I hope so that this is going to be very much clear to all of you guys. Clear? Alright. Then in the main section of the class, we have created the graph object, and here I have taken graph dot add edge, call that add edge function, and passed u comma v. Similarly add edge u comma v. If I have passed 0 comma 1, then the node edge will be added from 0 comma 1 to 1 comma 0 also, because it is undirected, so it will put both. And guys, you will add all the nodes like this. So I can create a graph out of this. What graph it is? Let us create this graph for this input. Let us create the graph. So this is 0, 0. Let us say this is 1. Okay. From 0 to 4 also it is there. This is 4. From 1 to 2 it is there. Let's say this is 2. From 1 to 3 also it is there. Okay. It is like this. 0 to 4, 2 to 4 is not there. 2 to 4 is not there. This part is not there. Okay. This is 1, this is 0, this is 4, this is 2, this is 3, and this is 1 to 4, it is done. 1 to 4 it is there. 2 to 3 it is there. Okay. And 3 to 4 it is there. 3 to 4 it is there. This is our graph basically. So 2 can be put up right here like this and like this, and this can be made it into a graph like this. This is our graph in this case. Cross check: 0 to 1, 0 to 4, 1 to 2, 1 to 3, 1 to 4, 2 to 3, 3 to 4. Yes, this is our graph. I hope so that this is very much clear. So if we create the adjacency matrix of this graph, it would be 0, 0, 1, 2, 3, 4, 1, 2, 3, 4, 0 to 0, 0, 0, 0, 0, 1 to 1 to 1, okay, 1 to 0, yes, 1 to 1 it is 0, 1 to 2 it is yes, 1 to 3 it is yes, 1 to 4 it is yes, 2 to 0 it is, 2 to 0 it is gonna be 2 to 0, 2 to 0, 2 to 0 it is gonna be 0, 2 to 1 yes, 2 to 2 no, 2 to 3 it is gonna be yes, 2 to 4 it is going to be 0, 3 to 0 it is gonna be 0, 3 to 1 yes, 3 to 2 yes, 3 to 3 0, and 3 to 4 it is gonna be yes, 4 to 0 yes, 4 to 1 yes, 4 to 2 0, 4 to 3 yes, and 4 to 0 0. So probably our matrix would look like somewhat like this. Okay guys. Where this is how it would look like. So if I run this code and if I check, the adjacency matrix would come like this. As you can see, 0 1 0 0 1 1 0 1 1 1 0 1. So it is printing the whole adjacency matrix. I hope so that this is very much clear to all of you guys. Okay. If you want, we can put up our own matrix to check once. If you are not understood this, then let us put our matrix, this matrix which we have created. So let us do it. We have edge from 0 to 1, 0 to 3, 0 to 1, 0 to 3, 0 to 1, 0 to 3 this will become. Okay, then we have 1 to 2, 1 to 3, 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 yes, correct. Then we have 2, 3, 2, 4, 2, 5, 2, 3, 2, 4, 2, 5, 2, 3, 2, 4, 2, 5, 2, 3, 2, 4 and 2, 5. Okay guys, 1, 0, 1, 2 is done, 3, 3 to 0 it is done, 3 to 1 it is done, 3 to 2 it is done, 3 to 4 it is there, 3 to 4 is left, 3 to 4 is left. So I am going to copy this, 3 to 4 it will be like this, and at last 4, 4 to 2 is there, 4 to 3 is done, 4 to 5 is left, 4 to 5 is left. So this is gonna be 4 to 5, and 5 to 2 and 5 to 4 is already done, 5 to 2 and 5 to 4 is already done. So this is it. So now when I run this program, it should print something like very nice, like, okay, so it did not print anything, that means we have missed adding any particular edge here. So let us check it once again guys. We will put this right here and we will put this right here, and let us check. Okay, let us check, let us check, let us check. 0 to 1 there is an edge, 0 to 3 there is one edge, 1 to 2 there is one edge. So if 0 to 1 it is there, that means 1 to 0 will also be there. 0 to 3 it is there, that means 3 to 0 will also be there. 1 to 3 it is there, 1 to 2 it is there, and 3 to 2 it is there. Okay, 1 to 3, 1 to 0 is already done, 1 to 3 it is done, 1 to 2 it is done. Okay, then for us 3 to 4, 0 to 1 edge is done, 1 to 2 it is done. Okay, let us count it like this. How many edges? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, done. Understood. 0 to 1 there is this edge. Okay, fine. 1 to 2 there is this edge. That is fine. 1 to 3 there is this edge. This is fine. 0 to 3 this is fine. Okay, 3 to 4 this is fine. 2 to 4 this is fine. Okay, 3 to 2 this is also fine. 2 to 5 this is also fine, and 4 to 5 this is also fine. It might be a problem where this is not printing. I guess so. Let us see what problem is this. Everything is fine. Our program works absolutely fine. Okay, let us make a simple graph and try to trace it here. If I trace it with, let us say make this as 0, this is 1, this is 2, this is 3, and this is 4. If I create something like this, okay, then it will be 0, 0, 1, 2, 3, 4, 1, 2, 3, 4. This is gonna be the matrix, guys. And according to this matrix, this will be 0, 0, 0, 0, 0, and from 0 to 1, yes, 0 to 2, 0 to 2, 0, and my camera will be shut down. Okay, 0 to 3, 0 to 3, this is gonna be 1, 0 to 4, this is gonna be 0, 1 to 0, 1, 1 to 2, this is gonna be 1, 1 to 3, this is gonna be 0, 1 to 4, it is gonna be, yes, 1. If it is 2, 0, 2 to 0, 0, 2 to 1, it is gonna be 1, 2 to 3, it is going to be 1, 2 to 4, it is gonna be 0, 3 to 1, 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 0, 3 to 0, it is 1, actually this is 1, this is 0, 3 to 2 it is 1, 3 to 4 it is going to be 1, 4 to 0, 0, 4 to 1, yes, 4 to 2 it is 0, 4 to 3 it is gonna be yes, like this. So now number of vertices in the code, oh yes, I absolutely did a mistake here. Yes, Jamil Rahman, absolutely correct. That is why it was not getting traced. I forgot about that. Yes, the number of vertices is more. 1, 2, 3, 4, 5, 6 vertices are there in total, correct? 6. Now this should work. Yep. Yeah, and yeah, Jamil Rahman, yes, correct, absolutely correct. And I started doing something else. Okay. See, this is the matrix as you can see. See, check it out. 0, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 0. Absolutely correct. Absolutely correct. Now you can see this. I'll zoom in a little bit here. Yep. Okay. Then 1, 0, 1, 1, 0, 0. 1, 0, 1, 1, 0, 0. Absolutely correct. Then we have 0, 1, 0, 1, 1, 1. 0, 1, 0, 1, 1, 1. Absolutely correct. Then 1, 1, 1, 0, 1, 0. 1, 1, 1, 0, 1, 0. Then 0, 0, 1, 1, 0, 1. 0, 0, 1, 1, 0, 1. Correct. 0, 1, 1, 0, 1, 1, 0. 0, 1, 1, 0, 1, 1, 0. This one. 5 to 1 do we have? Oh, 5 to 1. This is wrong. This part is wrong. It will be here. It will be 0. Okay. Yep. Okay, my code is absolutely correct, but my tracing was a little bit wrong. I hope so that this is very much clear to all of you guys. Thanks a lot, Jamil Rahman, to pointing out my mistake. Shout out for Jamil Rahman, and shout out to Jamil Rahman, and yep, thanks a lot, guys. So no matter whatever you will trace, your code will tell you that thing absolutely right. I hope so that this is very much clear to all of you. Appreciate that, Jamil Rahman. And I hope so that in today's concept you have understood the concept very well. Yes? Yes. Well, so this is your explanation about adjacency matrix and the graph representation, guys, and this is the code for it, where we have understood this really well, and this is a very easy code. Just vector of type vector and you will solve your issue. Well, guys, thank you so much, and yeah, we will keep the concept for today's class till here. In tomorrow's class I will be doing adjacency list. I will be telling you the adjacency list method of representation of graphs. So stay tuned for that. In tomorrow's class I will be doing that. Now tomorrow's class, it is going to be the same at 7 o'clock in the evening, and yep, alright, that's all, guys. Let us start the doubt session. If you have any doubts, please do let me know. If you don't have any doubts, we can switch off the session as usual. Well, I hope so that today I was able to explain you the concept of graphs representation. Clear, guys? That's it. Let us start the doubt session. You can start asking the doubts. If you don't have any doubts, thank you so much, guys, for watching. Do hit the like button in the live stream, and please share this live stream to many people as possible, so that those people also who are in need of learning DSA for free, they also get to know about it. Sir, we will be doing dynamic programming class. Yes, we will be doing dynamic programming class. After the graph session is over, I will be starting with, that will be my last topic in data structure concept, that is going to be dynamic programming. Yes, yes Anthony, yes Anthony, we will be doing dynamic programming definitely after the graph session. Yep. All right. So yep, do hit the like button in the live stream, and don't forget to like, share and subscribe to our channel guys, and don't forget to press the bell icon also so that you won't miss any future updates. Do follow and subscribe to our Telegram channel also, where we keep on posting all our interesting and important stuff related to all the live sessions. And yep guys, that's all for today's class guys. I hope so that you have liked the session, and do let me know about any doubts. If you have any doubts, I'll be there clearing all your doubts. And about session number 32, yes, I will be checking that and I'll be doing an update on that. So session number 32 will also be available very soon. I was actually outside the my office. I was outstationed at that time and I recorded that session. So it might be highly likely possible that it has not been uploaded yet properly, but yeah, I'll do something for that. So don't worry guys, I'll be doing that. Stay tuned for more such content, and thank you so much for watching me till the end. People like you inspire me to create more videos like this, and it allows me to come live and do all these concepts like this. So yes, thank you guys so much. That's all for this live session. I'll be ending up this live session. For more such content, stay tuned and subscribe to Coders Arcade. And also very soon I'm gonna start the batches for DSA offline and online both. So if you're interested, you can join me onto our Coders Arcade journey. Number and WhatsApp number and the Telegram channel link is already given in the description below. Go ahead and click onto that and join our Telegram channel. For the course and all, please do let us know. You have the company's mobile number in the about section of the channel, so please go ahead and call us. Correct guys? Well, that's it. Thank you guys so much for this live stream guys. I'll see you guys again tomorrow, so stay tuned. And yep, that's all for today's class. Take care, and I'll be signing off guys. This is Ashank David. Thank you so much. This is Ashank David signing off guys.